This is the last day on solving systems, and this time it's focused on the method called elimination. This is really the easiest of all the methods, at least in most cases. When we're using elimination, we're looking to eliminate one of the variables by combining the two equations. So when we look at these, we see that on the top one we have a plus y, and on the bottom we have a minus y. So what we want to do is we just want to add these two equations together. Okay, so 3x plus 2x is going to give us 5x. These y's, positive and negative y, are going to cancel out. And on the right, 14 plus 6 equals 20. So 5x equals 20 is what we get. Okay, nice and easy to solve. We get x equals 4. And then just like we did when we were doing substitution, we're now going to take this value for x and plug it in to one of these equations. Doesn't matter which one. I'm going to pick the top one because I like positive variables better than negative ones. So I'm going to plug it into the x in the top one. Doesn't matter if we use the bottom one, we would get the same answer. All right, so we have 3 times 4 plus y equals 14. Subtract 12 here. Y equals 2. Okay, write it as a coordinate point. In number 1, we had opposite variables. One was a positive y, one was a negative y. In this case, we have two variables that are the same, but they have the same sign. They're both positive. So if we were to add these together, instead of canceling, we would get 4x plus 8y equals negative 16. That doesn't help us. So instead, what we want to do, there's two different ways we can think about it. We can either subtract these two, okay, or we could change the bottom one by multiplying it by a negative. Okay, so this would become a negative 2x minus 3y equals positive 6. Okay, once we have that, if we combine it with the top one, okay, now these would cancel out because one's positive, one's negative. Positive 5 minus 3y gives us a 2y. Negative 10 plus 6 gives us negative 4. Okay, I find that it's easier to change one of the equations by switching all the signs and then adding them rather than starting to subtract, especially when you're subtracting negatives like you would be doing here. All right, plug it in. Doesn't matter which one. It could be the original, okay, or it could be the one that we switched the signs on. All of these will give us the same answer. I like positive numbers. Given that these are both pluses, top and bottom, I'm going to pick this bottom one because we have slightly smaller numbers to deal with. All right, so 2x plus 3y equals negative 6. Plug in a negative 2 for that y. So 2x plus negative 6 or minus 6 equals negative 6. Okay, we get 2x equals 0, and we move that to the other side, x equals 0. The extra step in elimination is when we have variables that won't combine to eliminate one of the two variables. So if we look at this, we have an x and a 3x. Adding those together or subtracting them doesn't cross it out. And then a 5y and a negative 7y, same issue. So what we want to do here is we want to change one of these equations. Let's look at the top one. Okay, if we want this x to match this one on the bottom, we want to put a 3 in front of it. Okay, now we also want one of these to be positive and one to be negative. So instead of multiplying by 3, let's multiply by negative 3. Okay, and this is going to get distributed in to everything in that equation. And it's going to give us this, negative 3x minus 15y equals negative 12. This equation here, I've just carried over to make it easier to see. So now if we were to add these, negative 3x plus 3x cancel out. This is going to give us a negative 22y equals negative 22. Okay, solve it. We get y equals 1. Go back and plug it in. Easiest one to plug it in this case is going to be this top one because we have that x by itself. So x plus 5 times 1 equals 4. Subtract that 5 and we get x equals negative 1. For certain problems, you're going to have to multiply both variables. So for example, we can't turn a 4 into a 6 unless we start dealing with fractions, which we don't want to do. Same thing with turning a 2 into a 5. So rather than just change one equation, let's change both of these. So our first step is going to be to decide on which variable we want to eliminate. So we can either make these x's the same value or the y's the same value. Let's do the x's. All right, so next question is what can we multiply both of these equations by to turn them into the same number? So a multiple of 4 is 12, and same thing with 6. So we can turn both these into a 12. To turn the 4 into a 12, we would have to multiply by 3. And to turn a 6 into a 12, we'd have to multiply by 2. We also want one of these to be a negative, so let's multiply that top one by negative 3. Okay, both of these distribute into everything in the equation. So we change our equations and we get these two new equations. The whole point of doing that is to getting two x's or two y's that are the same, x's in this case. So if we add those, they eliminate. Over here we have 19y, and over here, let's see, we're going to have 57. Okay, solve it, y equals 3. Go back and plug it in. We can pick any of the four equations. Let's pick the easiest one. Looks like that top one would be easiest. Oh, I picked the bottom one, it looks like. So plug that in for the y there. Okay, so we have 6x plus 6 equals 48. So 6x equals 42, x equals 7. We'd get that same x equals 7 if we pick the top one or any of these two that we had rearranged. This last one just throws a bit of a curveball at you because they're not lined up. The format's a little different, but we're going to solve this the same way. If we look at each equation, the x's are not on top of each other. We have 3x over 4y. Here we have 4x over 5x. And then these numbers are matched up at the end. So first step for this one is just to take everything and line them up. So we can do that by switching this to standard form for both of them. So in other words, we want to take this y and move it to the other side by doing minus 4y. Take this x and move it to the other side by doing minus 5x. All right, so that gives us these two equations. 3x minus 4y equals 2. Negative 5x plus 4y equals negative 6. When I write these, I'm always writing x on the left, y in the middle, number on the right. Once it looks like this, we can see it's nice and easy. So we have y's that when we add them together, they're going to cross out. So 3x minus 5x or plus negative 5x gives us negative 2x equals negative 4. Okay, so as a first step, just make sure everything is where it's supposed to be in the equation and rearrange it if that's not the case. X equals 2, plug it in, doesn't matter which one. Okay, I picked this bottom one here because we have 4y on that side. So plug in the 2 for that x there. 4y equals 4. That's a 4 here. Okay, so 5 times 2 is 10, minus 6 is 4, and then divide to get that last part of it. Oh, there it was. 2 comma 1.